Then I'll share my screen. Uh, would you confirm if you can see my screen?
Yes, yes.
Okay, good. So here's a presentation. So uh, we'll just go straight to the next, the first question, and it says the following. It says, let S be a positive integer. Then we need to prove that every interval S less than or equal to X less than or equal to 2S, inclusive of the endpoints, that is, will contain a power of 2. A power of 2 is simply a number of the form 2 raised to n, where n is an integer. So this is the question. I don't know if we should go to the solution, or there's anyone who is willing to make an attempt this, or get some ideas. It takes long to solve this problem, so you may not get the full idea on how to solve it, but if you have some starting ideas, you can share as well. Okay, so maybe I'll just go to the solution. So let's just be sure that you have gotten the question. So we are checking to see if, given any positive integer s, it's possible to find a number in between s and 2s, and that number must be a power of 2, and that can include the endpoints. So let's look at the solution. So solution says we pick s to be a positive integer as stated in the question. So we have two possibilities. Either s can be a power of 2, or it can fail to be a power of 2. But if it is a power of 2, then our work is easy. Then s can be written as 2 raised to r. And 2s will simply be equal to 2 raised to r plus 1. That simply means you multiply s by 2 and you get 2s. So you'll have found this already gives you 2 powers of 2 at the endpoints of that interval. So if s is a power of 2, that's the easy case. So the second option is to consider s when it's not a power of 2. And if it's not a power of 2, it must be between 2 powers of 2, and that will look something like this. It means s will be squeezed between 2 powers of 2. There must be some power of 2 on the left, and there must be some power of 2 on the right, and this should be strict inequality because s is not a power of 2. So we can just consider the left side of the inequality. If you multiply both sides of this by 2, you will have 2 raised to r plus 1 on this side and 2s on this side. So you get this other inequality, which says 2 raised to r plus 1 is less than 2s. That is simply by considering only the left side of this inequality. So from this, we can conclude the following. We know that already, if you consider the right-hand side of this inequality, we have s is less than 2 raised to r plus 1. So that gives us this first half. And this second inequality that we constructed gives us the second part of this inequality. 2 raised to r plus 1 will be less than 2s. So we have shown that if s is not an integer, we can always find a power of 2 between s and 2s. So that proves the problem at hand, what we intended to show. Is there any question on this?
It makes sense.
Yeah. Jeremy, you were saying something?
It makes sense. It makes sense.
Oh, okay. So let's look at the next question. This question says, let k be an integer. If the equation kx squared plus 4k minus 2 into brackets x plus 4k minus 7 is equal to 0 has an integer root, find the sum of all possible values of k. So we need to find all possible values of k that are valid, and then we add them to find their sum. Again, I can give the audience an opportunity to have a go at this. Okay, hopefully you have had enough time to get the question. Anyone wants to attempt it, or we move to the solution? Okay, so we'll move to the solution. Here it says let m, we have been told that we are looking for integer roots. So we are guaranteed that there'll be an integer root. So let's fix that integer root to be m. Then we can substitute the root into the equation. It will satisfy the equation. So where there is x, we just replace with m. If m is a root, then it will satisfy the equation. So based on this, we can rewrite it as if you pick all coefficients of k, we have m squared as the first coefficient of k, then 4k and m will give you 4m as the next coefficient of k, and then the other coefficient of k is here, it's 4. So you can put all that into brackets, and k is common, so we put it outside the brackets. Then we are left with anything that does not include k. One of them here is negative 2m, and the other one is negative 7. We shift all of them to the right-hand side to get 2m plus 7. So we can factorize this quadratic equation here, quadratic expression, as m plus 2 squared, k is equal to 2m plus 7. So so we what have I done wrong here? Oh yeah, this is fine. We just constructed a new number 3. So m plus 2, we are looking for a number because everything is in terms of m. If you can find a way to write it out as a number, then it's easy to find the possible values of m. So what we have here is the following. We have 2m plus 7 on that end, and m plus 2 is a factor of 2m plus 7. We already know that m plus 2 is a factor of 2m plus 7. So m plus 2 would be a factor of this term here. So we can add another multiple of m plus 2, or subtract another multiple of m plus 2. The resulting number will still be divisible by m plus 2. So we choose a multiple of 2, which will get rid of the m and leave us with a number on that end. So this one is just it's a construction. It's something you have to come up with so that you can end up with a number, and you look for the factors of that number. So in this case, m plus 2 will divide 3. So 3 is prime, so we have very few options for m plus 2. So m plus 2 can either be -1, sorry, if m plus 2 divides 3, then m plus 2 can either be -1 or 1 or 3 or -3. And in all those cases, if you work out, you'll get all the possible values of m as -5, -3, -1, or 1. So that simply means if you take if take m plus 2 to be 1, then m will be negative, will be what? M plus 2 is 1, means m will be -1, right? So 1 is a factor of 3. If m plus 2 is -3, then m is -5, and so on. So you keep doing that until you get all these 4 values. So we can, if we go back to this equation, we can plug in all these possible values of m and see which ones work. And when you do that, you will obtain only 2 distinct values for k. That will be 1 and 5. You can try that and see if it works. The only values of k that you will get that work will be 1 and 5. And if you add them, you will get 1 plus 5 is equal to 6. So we're looking for the sum of all possible values of k, and we have found them to be 1 plus 5 is equal to 6. Any questions on this one? So the trick here was at this point to find another number which is also divisible by m plus 2, but when added to this, we'll get rid of all the m's and leave you with just a number on this end, so that you can easily find the factors of that number, knowing that m plus 2 divides the number you find. In this case, the number is 3.
Wait, so here we're going off the sort of assumption that if the roots are positive, then the coefficients will be positive, such that m squared times k means that the right-hand side is divisible by m plus 2.
Pardon?
Like here we're sort of going off the observation that if a quadratic equation has integer roots, then its coefficients will also be integers, such that k will be an integer, to mean that 2m plus 7 is also divisible by m plus 2.
The reason k must be an integer is because this whole quantity is an integer, and then you also have an integer on this side. So this k must also be an integer.
Oh, I see.
You can see that.
Yeah, that makes sense.
Okay. So here's one more question. Today we are moving quite fast. I think that is good for us. We can finish earlier. So question 3 says find all possible positive integers n such that n plus 1 divides n squared plus 1. Any suggestions on how to proceed? Okay, so let's see how we can solve this. So we have, let's just go back to the question first. We need to find all values of positive integers n such that n plus 1 divides n squared plus 1. So we start by rewriting n squared plus 1 as n squared minus 1 plus 2, because negative 1 plus 2 is just 1. But this gives us a difference of squares, and we can factor it out as n minus 1, n plus 1. So this is deliberate because we needed a factor n plus 1. So this moves us closer to finding the values of n that make n plus 1 a factor of n squared plus 1. So we can subtract 2 from both sides. So n squared plus 1 minus 2 will be equal to n minus 1 and n plus 1. So, but we have some information already. We know that n plus 1 divides this first term, n squared plus 1. We want n plus 1, sorry, we want n plus 1 to be a factor of this first term. That can only happen if it's also a factor of the second term. So it must divide 2. N plus 1 must also divide 2. And that gives us n is equal to 1. To get 2. Or n is equal to, I think the only other option is negative 2. 2 plus 1 will give us 3, so that won't work. I think this should be negative 2. But we wanted positive integers, right? So I think the only is it only n is equal to 1? I think the question wanted positive. Yes. I don't know why I have 2 there. N can only be 1. If you have 2, we'll have 2 plus 1, which gives us 3, which does not divide 2. But if it was negative 2, you will get negative 1, which divides 2, but we don't need the negative values of n. So I think I left out a negative here. Any questions on this? Is it clear?
Yeah, it's clear.
Okay, good. So I'll move on to the next question.
Wait, what if we say that n equals 0 such that n plus 1 equals 1?
We are looking for positive integers.
Oh, okay.
0, if we say non-negative, then 0 can count. But but 0 would work if you're looking for non-negative integers. So we want to focus on only positive. This second one, I'm not sure why I have it there. If I had checked carefully earlier, I would have removed it. It shouldn't be there. So that makes sense? So positive usually means greater than 0. If you want to include 0, you normally say non-negative integers.
And if I may ask, can you go back one? Yeah. If I may ask, if it were n squared plus 2, now when we are trying to make the opposite side, the right-hand side, a difference of 2 squares, we just find what to add there, guided by the n squared plus, whether it's 1 or 3.
Did I get the question correct? Let me.
I think if it's n squared plus 2, maybe we'd subtract 3 such that we now have n squared minus 1. such that now we're looking for the factors of the 3 that we subtracted. Or if it's n squared plus 5, then we'll subtract 6, such that we remain with the n squared minus 1, then we do difference of 2 squares there.
Okay, thank you.
Okay, yeah, okay. I think Jeremy maybe got the question before I did. So I think he's right. Thank you, Jeremy, for the answer. So it's just a, yeah, you can set, twist this question any way you want and have different versions of it so that you get different answers as well. So you can keep changing this value. So that
Can you just briefly go back to the question? Just one moment, please.
Okay.
Okay, thank you.
You have it. So this is the last question for today. Shouldn't be too hard to solve if you are given a few minutes. It says if B over A is equal to 2 and C over B is equal to 3, what is the ratio of A plus B to B plus C? So should I let you try this or?
Yeah, just a few minutes.
Okay.
I'm getting 3:7.
Pardon?
I'm getting 3:7, but yeah, let me confirm.
You missed something somewhere, I think. Unless I also wrote the different, no, I think I wrote it correctly.
I'm getting 5 to 12.
Okay. Do you want us to look at the answer? Then you compare with yours?
Can you just have 1 minute?
Okay.
No. This would be 6, 16, 9 to 12, 3 to 4.
Wait, sorry, 3:8.
Yes, now 3 to 8 is correct. We can
Yes,
see.
yeah, I messed up somewhere. Yeah, the last step.
Okay, so we'll just look at the answer. Or do you want us to tell us how you solved it?
Okay, so I just found both B and C in terms of A. So from the first question, you can find that B equals 2A. And then now from the second one, C equals 3B. And since we know that B equals 2A, then that means C equals 6A. So we know that the value of B as 2A and C as 6A. Then now when we plug into A plus B and B plus C, then A plus B will be 3A, and then B plus C will be 8A. Then the ratio there is 3:8.
Yeah, that works. It's the same idea as we used, though we didn't use A. We used B instead. So we have B over A is equal to 2. And A is which means you can write A as B over 2. We had C over B is equal to 3, which gives you C is equal to 3B. Now from here you can, since C is 3B, B plus C will be 4B. And A plus B will simply be over 2, will be equal to B over 2 plus B. And that simplifies to 3B over 2. So if you get the ratio of A plus B over B plus C, this is what you obtain. And it simplifies to 3 over 8. So this one was worth attempting, I think. It's not too involving. Yes. Any questions?
Yes, sir. Yeah. Karori speaking.
Yes, Joseph.
Yeah. Maybe go back maybe to the question. Maybe I can also put some input.
The initial question. This one.
Yeah. This is the initial question, right?
Yes. The one you want the first question or this one?
This one. This number 4.
Yes.
Alternative, we can have the B over A is equals 2/1. And then also we can, somewhere I don't have a Bible pen, I'm in a certain meeting, but also the C over B can also be 3/1. And then from there you make B the same value.
Yeah.
And then from there you can quote the ratio very fast by comparing.
Okay.
It can also work.
Yeah, I did something similar, but now using A throughout.
Yeah.
It looks like this one has multiple solutions.
I actually
Yes, this is a high school question. I think we are conversant with this one.
Yes. Yeah, today I didn't want to bring any. I wanted to bring reasonably easy questions to solve, so that we have a mix of tough questions and easy questions.
That's great. That's great. Yeah.
Yes. Any questions or comments?
Yeah, maybe reaction from the previous contest, which was held on Saturday.
What?
You're getting me? Yeah.
Yes.
Yeah. From the previous exposition of your content,
yes,
we had some presentation. Maybe in future, maybe you can quote a few problems coming from your presentation, so that the student who follow the class can benefit.
So
that's my
you want us to specify if they come from a previous.
Yeah, inclusion of a few questions coming from this presentation.
So for the current contest, the one we just did.
Yeah, I didn't see any maybe what you have presented previously.
Okay. I don't know. We can arrange for that, and I have. I wanted to make this the last one for this year. I don't know if people in the middle of December will people be available, or they'll be getting ready for Christmas.
Maybe we can say maybe you can give us a break, a Christmas break, and then resume on January.
Resume in January. That's what I thought.
Yeah, this is.
Maybe we can try one and see the numbers.
We try one because the next one would be 13th December.
That's okay. That's okay.
Yeah, then you just see the numbers.
Okay. Maybe from the ones who are here, we can ask. Would anyone want us to do one more?
Yes.
Yeah.
That next. Yeah. Okay.
So we can do one last one then in 2 weeks' time.
Yeah.
Yes.
Okay.
Really appreciate.
That would be great then.
Maybe another addition.
Yes.
From your presentation of the 4 questions, maybe you can have similar problems left for the audience or the runners to try to attempt a similar method. I think to gain more.
It's true. I was pressed for time. Actually, I wanted to get a few more questions today, but I had to focus on just the ones I could present because of time.
It's okay. It's okay.
But that's a good idea. It actually works best because we want people to be able to enjoy solving these problems.
Yeah.
Yes.
Great. Thank you for presentation.
Thank you.